I now want to look at some fundamental identities of trig functions. The first identities I want to look at are the reciprocal identities. A lot of the trig functions are just reciprocals of one another. As an example, sine of theta is opposite over hypotenuse, but cosecant is hypotenuse over opposite. So sine of theta is 1 over cosecant theta. Similarly, cosecant theta is 1 over sine theta. Cosine is 1 over secant theta. And secant theta is 1 over cosine theta. And tangent theta is 1 over cotangent theta. Similarly, cotangent theta is 1 over tangent theta. Using these identities, if we know the sine of the angle, the cosine of the angle, and the tangent of the angle, we can actually get all 6 of our trig functions of a single angle using only these 3 and their reciprocal identities. Next up is the quotient identities. The quotient identities say that tangent of theta is equal to sine of theta over cosine of theta, and cotangent of theta is equal to cosine theta over sine theta. We know that sine theta is equal to the opposite divided by the hypotenuse. Cosine is adjacent divided by hypotenuse, but when we divide by fractions, we flip it and multiply. So I can see that when I divide these two, I end up with the opposite side over the adjacent side, which is just equal to tangent. So this tells me that I don't even need 3 trig functions. I only need 2. If I have sine and I have cosine, I can find all 6 of my trig functions. Let's suppose that sine of theta is 2 over 3 and cosine of theta is square root of 5 over 3. I want to find the rest of my trig functions. Well, cosecant of theta is 1 over sine, or 3 over 2, since it just flips the fraction over. Secant of theta is 1 over cosine, which is 3 divided by the square root of 5, or if we rationalize the denominator, 3 root 5 over 5. Next, we have tangent of theta, which is sine divided by cosine. And remember, when I divide by a fraction, I flip it and multiply. My 3's cancel. I'm left with 2 over the square root of 5. I can multiply both the top and the bottom by the square root of 5 to get 2 square root of 5 over 5 for my tangent. Cotangent was cosine divided by sine, so we have square root of 5 over 3 divided by 2 over 3, or square root of 5 over 3 times 3 over 2. My 3's cancel, and I'm left with square root of 5 over 2. So now I have all 6 of my trig functions. My next identities are the Pythagorean identities. Let's consider a right triangle. We'll call the opposite side A, the adjacent side B, and the hypotenuse C. The Pythagorean theorem tells me that a squared plus b squared is equal to c squared. And then I'm actually going to divide everything by c squared. When I do, I have a squared over c squared plus b squared over c squared is equal to c squared over c squared. Or a over c squared plus b over c squared is equal to 1. And when I look at this in terms of the angle, a over c is opposite over hypotenuse. In other words, it's sine. So this is sine squared theta. B over c is adjacent over hypotenuse. or cosine, so this is cosine squared theta, is equal to 1. And this is the first of my 3 Pythagorean identities. So we'll go ahead and box it in to remind us that it is important. My other 2 Pythagorean identities can be derived from this. I'm going to start by dividing everything by sine squared of theta. So I have sine squared theta over sine squared theta, cosine squared theta over sine squared theta is equal to 1 over sine squared theta. So this is 1. We know cosine over sine is cotangent, so this is cotangent squared theta. And we know 1 over sine is cosecant, so this is cosecant squared theta. So this is my second of my trig identities. I'm going to take my sine squared plus cosine squared equal to 1 and divide everything by cosine squared theta. So I have sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta is equal to 1 over cosine squared theta. Sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. So here is my third and final Pythagorean identity. Tangent squared plus 1 is equal to secant squared. Let's suppose an acute angle has sine of theta equal to 1/2. What is cosine of theta? Well, I know that sine squared plus cosine of theta squared is equal to 1. So this is 1/4 plus cosine squared theta is equal to 1. And if I subtract 1/4 from both sides, I have that cosine squared theta is equal to 3 over 4. Taking the square root of both sides, the square root of 3, we just write as the square root of 3, and the square root of 4 is 2. So if I know sine of theta is 1/2, cosine of theta must be equal to square root of 3 over 2.